Today we're going to be talking about properties of trapezoids. First, we want to begin discussing what makes a trapezoid a trapezoid. To begin with, it's a quadrilateral, so it has four sides. And more specifically, it has one pair of parallel sides. So as you can see up here, this is our pair of parallel sides, which makes this a transversal and this a transversal. Now, as we take a trip back to just olden days where we had a parallel set of lines and a transversal, we knew that angles 1 and 2 were consecutive interior, and that meant that they were supplementary, which means that angles 1 and 2 right here are consecutive interior and make them supplementary, and also angles 3 and 4 are also consecutive interior, making them supplementary. But not 1 and 3, just 1 and 2 and 3 and 4. Why not all the way around in like a parallelogram or a square or a rectangle? Because you only have one pair of parallel sides, not two pairs. And that's what makes a trapezoid so distinctly different from the rest. So in your notes, you want to make sure that you highlight the fact that we have one pair of parallel sides and that we have consecutive angles are supplementary. For isosceles trapezoids, we'll have the diagonals be congruent. These guys right here are congruent. The base angles are congruent, so right here and right here are the same, and right here and right here are the same. And unlike a parallelogram, opposite angles are supplementary. And why is that? Well, if these two are supplementary, right? If these add up to be 180, and this angle is the same as that angle, then obviously these two add up to be 180 as well. Let's take a look at this in practice. As you'll notice in every question, I try to bring in the properties that we're going to use to help us solve the questions. So over here I see that I have 62 degrees, and these two angles right here are supplementary. So 180 minus 62 would give me the measure of angle D. And these two right here are supplementary. So 180 minus 31 should give me the measure of angle C. And if I add all four angles up, I should get 360. So press pause and get an answer for angle C and angle D. Press pause now and work this one out on your own. Press pause and do your own math repeatedly throughout the video. So here are the values I got. I got the measure of angle C as 149 degrees and the measure of angle D is 118. And up here, I do my check. I add all four angles and I get 360 degrees. So that seems to be like we got the right answers. All right. Now I want you to complete number 1. Then move on. So after we get past number 1 and 2, we bump into algebra immediately. And what do we notice? I'm dealing with consecutive interior angles of parallel lines, which makes them supplementary. So 12x plus 3 plus 7x minus 13 equals 180. Now we're going to combine like terms. Right? That's what's going on here. So no inverse operations. 12x plus 7x going to give us 19x, and then we got positive 3 and negative 13. Well, that's going to be the difference of those two numbers is going to be negative because there's more negatives than positives, and 13 minus 3 is 10 equals 180. I'm going to add 10 to both sides, right? And I'm using now my inverse operations to solve the problem, and I'm going to get 19x is equal to 190. Divide by 19 on both sides, and I'm going to get x is 10. Now, they want me to find the measure of angle R, so I got that x is 10, but I'm not done. I look over here, angle R is 7x minus 13, so 7 times 10 minus 13 is going to be 70 minus 13, which is 57 degrees is equal to the measure of angle R. And that's our final answer. X is 10 helped us get there, but the final answer is 57 degrees. Now, you complete number 3. Our next set of questions deals with isosceles trapezoids, right? So isosceles trapezoids, what do we know? We know that angle G is congruent to angle F, and we know that angle D is congruent to angle E. I know that angle D plus G equals 180, and lots of other stuff like that. So these are the things that I'm going in, right? Diagonals are congruent, base angles are congruent, opposite angles are supplementary. And so what are we talking about here? Right here, I notice we're dealing with segments. So I know that I'm not dealing with any angle business. So we see DG is here, and then DF is here. So DG is going to be congruent to the other leg. So isosceles trapezoids are trapezoids that have congruent legs. So segment DG is congruent to segment EF. And segment DF, the diagonal, is congruent to the other diagonal. So segment EG or GE. Let's move on to the next question. We're dealing with angles. So now our angle information is on the table and the segment stuff is off the table. My focus is on these two right here. So I see angle T is right here, and that's an obtuse angle. So an obtuse angle could only be congruent to another obtuse angle. So angle T and angle U are congruent, and angle W is congruent to angle V. And that's that. As we continue on to number 8, we're still dealing with an isosceles trapezoid. How do I know? Congruent legs. So again, a lot of stuff happens quick here. Got some congruent angles, so I know that X and Y are supplementary. I also know that W and Y are supplementary. I know that Z and X are supplementary. And I know that W and Z are also supplementary. So we're kind of going around there. I also know that's really simple. These guys are congruent, and these guys are congruent. So all I need to do is just subtract 47 from 180, and I'll have the other value. So 180 minus 47 gets us 133. Now, 133 goes in 2 places, and 47 goes in the other 2 places. So 47 is here. And then that's it. I got my two 47-degree angles. Now, my 133-degree angles are down here. And if you add 133 and 133 and 47 and 47, you should get 360, and we do. So, angle W, 47 degrees, angle Y, 133 degrees, angle Z, 133 degrees. And again, fill out the picture. Then answer the questions. Now, as always, as we move on, all we're doing now is separating the information from the picture. We're not putting it in there for you. So we see MP, and again, this doesn't have anything to do with angles at this moment. So I see NP, NO, PN, MO. So let's take a look. What do we know, right? We know that MP, segment MP, is congruent to NO. We also know that segment MO is congruent to PN. Right? Those are our two known pieces. Let me just clean this up a bit. And now the diagonals are congruent. That would be the MOPN piece. And the legs are congruent is the MP and O piece. So what do we have? Well, we have a little bit of everything. So how about we just grab one and make a statement that works. So I see MP, and MP and NO are going to be the same. So I'm going to take these two, and I'm going to set them equal to each other. 16x minus 13 equals 9x plus 8. Now there's no combining like terms to be done here. We're just going to go straight into inverse operations. Subtract 9x, subtract 9x, and I get 16x minus 9x is going to be 7x minus 13 comes down, equals, that cancels out, positive 8 comes down. Add 13, and lo and behold, 7x is equal to 21, x is equal to 3. Okay, that's good. So we solve for x, check. Next on our plate is to solve for y. So one of the y statements or expressions is Pn, and the other one is Mo. And what do I know about Pn and Mo? They're congruent. So 5y plus 19 equals 12y minus 37. I mean, you just can't help but begin to improve your algebra if you're really trying this. All right, now, why did I subtract 5y instead of 12y? Because I want to keep the coefficient of y positive, right? 12 minus 5 is 7. That's the coefficient, that number attached to the variable. Negative 37 drops down. Positive 19 drops down. I add 37 to both sides. I get 56 equals 7y, and y is going to be equal to 8. And now I solve for y. Check. So we're good to go here. Let's kind of move on together for number 10. Again, the first thing I see here is that we're referring to angle D and angle C. They're telling me this is an isosceles trapezoid. They either have to tell me or they have to give me the actual tick marks. So what do I know? I know that base angles, right? These are the base angles here, and then the other base angles are up here. I know that base angles are congruent. So 2x plus 27 equals 5x minus 12. Okay, which side should we move x to? I think I'm going to subtract 2x because 5 minus 2 is positive as opposed to 2 minus 5. 27 equals 3x minus 12. Add 12, add 12. We're going to get 39 equals 3x divided by 3, divided by 3, x equals 13. Great. Now, what do I notice? I notice I need all four angles. All I have is x. So the first thing I'm going to do is substitute 13 in for x into both of these and make sure that I get the same answer. So I have 2 times 13 plus 27 is equal to 26 plus 27, which I get 53. And I do 5 times 13 minus 12. And 5 times 13 is 65. Minus 12 is 53. So that's good. So I know that B and C are both 53 degrees. Now, I know that the opposite angles are supplementary. I also know the consecutive angles are supplementary. So 180 minus 53 is going to give us 127. So 127 must be the other two angles. And when I look here, this is an obtuse angle. So that's an obtuse measurement, so that makes sense. And when I add all of this up, 127 twice plus 53 twice gets me 360. Good to go. We're all set. Let's move on. Now for isosceles trapezoids, I know that the legs are congruent, and I know that these base angles are congruent, and I know that these base angles are congruent. But what about these two right here? Well, whatever's true about regular trapezoids is true about isosceles trapezoids. Consecutive angles are supplementary, as well as the opposite angles are supplementary. But these, M and I, are consecutive interior. So I know that 10x minus 33 plus 4x plus 17 is equal to 180. Now again, we're going to combine like terms. Be careful not to do inverse operations here. We're not crossing over that equal sign. We're just pushing 10x, 4x together, so that's 14x. And then negative 33 plus 17, well, it's going to be a minus. And 33 minus 17 is going to be 16 equals 180. Add 16, add 16. We're going to get 14x is equal to 196. And when I divide by 14 on both sides, I believe I get 14. Now that we got that x is 14, we can get the measure of angle J. Right? The measure of angle J is equal to 10 times 14 minus 33, which is 107 degrees. So 107. And now J and K are the same, so this is 107 degrees. Then we come down for the measure of angle M is equal to 4 times 14 plus 17, right here. And that gives us 73 degrees. So the measure of angle M is 73 degrees. But also, so is angle L, right? Because these guys are base angles, and base angles are congruent. So I got 73 degrees. And when I add it all up, I do in fact get 180, or I'm sorry, 360, because these two add up to be 180, and two 180s is 360. And that's the sum of all the angles in a quadrilateral, so we're looking good. Last one. I see that we have angles here. Okay, and what kind of angles are these? These are opposite angles of an isosceles trapezoid. Opposite angles of an isosceles trapezoid are supplementary again. 14x minus 25 plus 3x plus 1 equals 180. So what are we going to do? We're going to combine like terms, right? Don't change your signs. Just push them together. That's 17x. And I got a minus 25 and a plus 1. There's more minuses than pluses, so it's a minus. 25 minus 1 is 24 equals 180. Add 24, add 24. I get 17x, cancels. 4, 10, 12, 4, divided by 17, divided by 17, x equals 12. Now again, we got to get the measures of all the angles. So who's congruent to who? S and T are the same. And then V and U are the same, right? Those are the congruent base angles. So for angle T, 3 times 12, right? The measure of angle T, 3 times 12 plus 1 is going to be 36 plus 1, which is 37. So angle T is 37 degrees. Who else is? Angle S. So that's 37 degrees. Now I know that 180 minus 37 is going to be the measure of the other angle, right? So when I subtract that, I get 143. So it should be that these are 143 degrees. I don't have to substitute in to actually answer it, but I am going to choose to do that. So I'm going to come down here for angle V and say 14 times 12 minus 25 and see what we get. Well, 14 times 12 is 168 minus 25 is, lo and behold, 143. So these answers are good to go. And if you add them all up, you actually do get 360. So there's so many ways that you can check your answers. And I suggest checking your answer. So what now? You should complete all the homework problems in the notes section. We've done most of them in the video, numbers 1 through 14. And then go to homework number 6, and you're going to complete numbers 1 through 10. Now just be careful, that's not 100% of homework number 6. You're stopping at 10. Okay? Stop at 10 in the homework section. And we'll see you next class.